In this Maths Olympiad question, we need to find the integers a and b such that 9 to the power of a minus 4 to the power of b equals 17. So here's our left-hand side, 9 to the power of a minus 4 to the power of b. We want that to equal 17. So we could do some educated guesses here, pick some a's and b's that we think would work, put them in. We might find the right answer, but that wouldn't prove that that was the only answer. There might be some more out there. It leaves quite a lot up in the air. So let's find a way of doing this without any guesses that will definitely get us all of the answers. So the first thing I'd notice is that we've got a 9, which is a square number, and a 4, which is a square number, and we're subtracting. So the difference of two squares comes to mind. But the difference of two squares works when you've got one number squared minus another number squared. Our powers here are different, but with a bit of rearranging, we can get this into the right format. So 9 is 3 squared, and 4 is 2 squared. So we substitute those in. Now, by the rules of indices, if we've got a power of a power, this would equal those two powers multiplied together, which also means we can switch the powers around. So 3 squared to the power of a is exactly the same as 3 to the power of a squared, and 2 squared to the power of b becomes 2 to the power of b squared. So now we've got the difference of two squares. So applying our rule, we know that this must be equal to 3 to the a plus 2 to the b multiplied by 3 to the a minus 2 to the b. And we want this to equal 17. Well, 17 has only got two whole numbers that multiply together to make it. It must be either 1 times 17 or 17 times 1. And we know we're looking for whole numbers because 2, 3, a and b are all integers. So the answers of the brackets must be integers as well. Looking at those two brackets, they've got the same numbers as one is adding together. We know they're going to be positive because 3 and 2 are positive. Our left-hand bracket with the addition must be 17, and the right-hand bracket with subtraction must be equal to 1. We've got a couple of simultaneous equations now. If we were to add those two equations together, the two b's would cancel out. We'd end up with 2 lots of 3a, and then the 17 plus the 1 gives us 18. Dividing by 2, get 3 to the power of a is equal to 9. Well, 3 squared is 9, so a must be equal to 2. We can now put this into either of our two equations. So putting it into the addition one, we get 3 squared plus 2 to the power of b equals 17. 3 squared is 9, so taking that away from both sides, we get that 2 to the power of b is equal to 8. b must be equal to 3, and they are the only solutions to be found. If you've enjoyed this video, don't forget to subscribe to the Doing Maths channel or check out some more of my videos by clicking on the links here.